Okay, welcome back to pre-calculus. This lecture covers factoring. So for example, we can factor a plus b out of the following polynomial 2x times a plus b minus 3y times a plus b. And we get a plus b times 2x minus 3y. So we can see a plus b is common in both terms. So normally the solution will be 2x minus 3y times a plus b. And we call these techniques factoring by grouping. So let's see one example. Here they say we should factor 5x minus 5y plus bx minus by. So here we can see that in the first two terms, 5 is common. In the next two terms, b is common. So it's the same as writing 5x minus y plus bs minus y. S minus y is common in both terms, so we have s minus y, then we have 5 plus b. So here we say we can factor this polynomial by using of grouping. The grouping is done so that the common factors, frequently binomial factors, can be removed. So here we have again 5 is common with 5s minus 5y. So we get 5 times s minus y. Also b is common for bs minus by. So we get plus b s minus y. So since s minus y is common, we have s minus y times b plus 5. Now we can use the formula for multiply two binomials also to factor certain trinomials. So this is the formula. If I have x plus a times x plus b, we multiply s times s will give us s squared. S times a will give me xa, and also a times s will give me xa and sb, sorry. So sa plus sb is the same as writing a plus b and x out. Then we have a times b, so that will give us ab. So we can be used to factor trinomials such as s squared minus 7s plus 6. Now let's go back to the example here. We can see that we have a and b here. So if I have a trinomial, it means if I'm looking for a number that if I multiply a and b, I'll get that value. And when I add those two a and b, I'll get the second value. So to factor a trinomial x squared minus 7x plus 6, we are looking for a value that when we multiply, we get 6. And the same values when we add, we get minus 7. So this will be minus 1 times minus 6. So minus 1 times minus 6 will give me plus 6. Minus 1 plus minus 6 will give me minus 7. So that's the whole concept here. X plus a times s plus b. We have s times s will give s squared. S times b is bs. A times s is as. So a plus b and x. Then a times b. And this is a trinomial now. So we can get a trinomial, then we factorize to get two binomials. So let's see this example. S squared minus 7s plus 6. We have, again, x plus a, s plus b. So we are looking for the value of a and b. In this case, it will be minus 6 minus 1. Because minus 6 times minus 1 will give me again plus 6. Minus 6 minus 1 plus will give me minus 7. So that's what we write here. S squared minus 7s plus 6. We should get s squared plus a plus b, x, then plus ab. So we are looking for a and b now. As we said earlier, a and b should be -1 and -6. So if I multiply -1 and -6, I get plus 6. If I had -1 and -6, I'll get -7. So that's what we said here. In order to get -7, to combine a plus b, we need -6 plus -1. That will give us -7. In order to get 6, we need -1 times -6. So that will give us +6. So our final solution will be x minus 1 and times s minus 6. So let's see the step-by-step here also. Here we have example to factor 9s squared minus 31x plus 12. So first, we form the product of the second degree term and also the constant term. So which will be what? 31 and 12. So here we say 9s squared times 12 will give me 108x squared. Now we are going to determine whether there are any factors of the product of step 1 that will sum to the middle term of the trinomial. The middle term of the trinomial is minus 31. Now, if the answer is no, then we say the trinomial will not factor into 2 binomials. But if it's yes, then it can be factored into 2 binomials. So the factors will be minus 27x and minus 4s. Minus 27x and minus 4s will give me the sum of minus 31x. So that's perfect. So now we have to use the sum of these factors to replace the middle term of the trinomial. So 9s squared minus 3s plus 12, I'm going to replace minus 31x with minus 27x and minus 4x. And that will give us 9s squared minus 27x plus minus 4x plus 12. So we know 9 is common. S also is common because 9 and 3 is possible. We get 3. S squared and S, we get x. So 9s is common. We have s minus 3 because 9s squared times s will give us 9x. And the same thing, 27 divided by 9 will give us 3, and it's negative. S will cancel x. Here also we have 4 is common. So we take negative 4 out. So negative 4x divided by negative 4 will give me x. Then we also have 12 and negative 4 will give me negative 3. So now we can see s minus 3, s minus 3. So again, we do by grouping. We have 9s minus 4 times x minus 3. Now here also we say some special products that make factoring easier are as following. We have something we call the perfect square trinomials. For example, x plus a all square is the same as s squared plus 2as plus a squared. Or x minus a squared will give me s squared minus 2ax plus a squared. Now, if you want to know if this is correct, we can just multiply s minus a times s minus a, and that will give us s squared minus 2ax plus a squared. Now, also, we have what we call the difference of two squares. So if I have s squared minus a squared is the same as saying x plus a times s minus a. That's why it's called difference of two squares. Again, to prove it, multiply x plus a by s minus a, you will get s squared minus a squared. Because here we can see that plus a times s will give me plus as. Now minus a times x also will give me what? Minus as. So plus ax will cancel minus ax. Then we have s times s, which is s squared, plus a times minus a will give me minus a squared. And normally we call this difference of two squares. Now here they say we should factor 25x squared minus 36y squared. We can see that this is a difference of two squared because 25 is the same as saying 5. Excuse me. It's the same as saying 5 squared. So we can rewrite 25 as 5 squared. And we also can rewrite 36 as 6 squared. So this means we get 25s squared minus 36s squared will give us 5x all squared minus 6s all squared. So it's difference of two squares, which will give us 5x minus 6y times 5x plus 6y. So we say these two factors are called binomial conjugates because they differ in only one sign, minus and plus. Now, most of the polynomials we are factor here we say have been second-degree polynomials. But sometimes when we say second-degree polynomial means the exponent is 2. Sometimes we may have exponent greater than 2. For example, here we have a 4th degree, s to the power 4 plus 4s squared plus 4. And first, we can convert saying that, okay, a equal to x squared. So instead of writing s to the power 4, we are going to write a squared, because s squared will give us s to the power 4. So a will be a squared plus 4a plus 4. Then we can factorize a squared plus 4a plus 4. The answer we get, then we are going to substitute s squared with a. So here we say a polynomial is said to be factored completely if all the possible factorizations have been completed. For example, if we have 2s minus 4, s plus 3, it's not factored completely. Why? Because 2 can still be factored out of 2s minus 4. So we can take 2 out and we get s minus 2. So to be factored completely, our answer will be 2 times s minus 2 times s plus 3. And that's the concept again of if the degree of the, as we say here, if the degree, let's say 4/5 degree of the first, the exponent, the x value, or we say the variable, then sometimes we may factor more than once. So this is the guideline for factoring completely. First of all, look for common monomial factors first, if it's possible. Then difference of two squares, if the expression is a binomial, or if it's a trinomial squares, then other method of factoring trinomials. And also possible you can factor by grouping. Normally factor by grouping, we should have 4-term polynomials. So we may have binomial, trinomial, or 4-term polynomials. So let's see example here. They say we should factor completely. We have 12s squared minus 36s plus 27. I can see that 3 is common in all these values. So let's see the solution here. We take 3 out. Since 3 is common in 12s squared minus 36s plus 27, we take the 3 out. Now we know 12s squared divided by 3 will give us 4s squared. Now minus 36x divided by 3 will give us minus 12x. Then 27 divided by 3 will give us plus 9. So here we can see that it's possible we can continue. So we were able to convert, this is again a perfect square, and we get 2s minus 3 all square. Now let's try the next example. We have 16s squared minus 64y squared. Here we can see that 16 is common, so we bring our 16 out, we get s squared minus 4y squared. So this is a perfect square because we can see 4 is the same as 2 squared. So we get s squared minus 2y all squared. So that will give us a difference of 2 squared, and the answer will be s plus 2y, also s minus 2y, then times the 16. Now, factoring the difference of 2 squares immediately will give us 4x minus 8y and 4s plus 8y, which is not factored completely because we could still factor what? 4 from 4s plus 8y and also 4 from 4s minus 8y. So we get almost the same answers. So that will be the conclusion of these lectures. Again, these lectures we learn how to factor binomial, trinomial, and also 4-term polynomials using again factoring by grouping. Thank you and see you in the next lectures.